do you need so many sensors?
So
why do you need a faster car?
And this is a challenge. This is something that I've seen. If I'm just programming gestures, like so the first gesture I programmed was to just move your thumb, and it does an alt tab. So I only really needed the distal IMU, and I'm just looking for an event where the angular rotation makes a sharp peak. So you can see it doesn't just look at that. It also has back or flail around. So something I'm going to write next is for looking at this graph here, you can see the peaks now. So if I look at...
So you could make the world's most complicated player piano.
You could. So that was one application. We demoed this at a pitch day event at Tech Shop, and we tried to do the music thing, and no one understood it. They didn't understand what it was for.
Really?
Yeah, they were like, what? They didn't get it.
This is a tech shop, they don't get it?
We didn't have this much visualization at that demo.
The what?
We didn't have any of this visualization at that demo.
It was just us standing up like, this can do great things if you swear.
If you actually do a what do you call it, a pressure sensor on top of it, you pick that baby on a junior school student, and it'd be really cool.
Yeah.
Ben sensors have a lot of manufacturability issues. So there have been a number of gloves that have tried to use the Ben sensors to get the articulation angles.
What's that?
On the right?
Yeah.
Go ahead.
Yeah, that's one where the other guy that's not here right now, he's working on that one. That's another 3JS render, and that's using quaternions. So quaternions you can derive from rotation and acceleration, and use mag for error correction, and that gets you position. So if you want to know, this is the actual application that I think makes the most sense, which is VR. So in VR, now you really care about the details of where your hands are and where your fingers are moving, and if you can get those precise gestures, and that's where that'll be.
That's like through math or something?
Oh, so yes, the quaternion is what. So for when I move my hand up like this, I get an acceleration event, I get some angular rotation, and some the mag stuff doesn't change all that much. But where is my hand actually? Right. How do I map that? And that's what quaternion gives you position tracking.
That's pretty cool. So you're going to give the white dot guys a little run for their money.
What are the white dot guys?
Well, the way they normally do that in movies is they will put dots at every joint.
Oh.
And you just go around looking like a fool.
Yeah. Instead, wear this.
How many cameras?
Oh, yeah.
30 cameras?
They will have the opposite problem that we have. Our problem is because we have inertia very accurately. I mean, to the point where I can tell you that the gravity at our altitude is 0.96 Gs. So, like if someone tells you that gravity is 9.8 meters per second squared, they're assuming you're at sea level. But as you get higher off of sea level, the gravity drops. So at Phoenix, the gravity is 0.96 G, according to those sensors. So we have inertial data really clearly, but we have to integrate twice in order to get position. They're going the other way. Because they're using optical, they have position as accurately as we have inertia, but depending on your application, sometimes you don't care about one or the other. So there's overlap. But both of us are, like both strategies are going to be struggling to get velocity, suppose. So the quaternion renders on the right, that's all the data coming out. What's the frame rate, Brent? What's it telling you? 38? Okay. Those quaternion renders, the idea is that we would have a kinematic model of the hand with those boxes joined end to end so that the rotation of each individual bone ends up culminating in producing the shape of the hand. So as long as the rotation vectors are accurate, then that's what happens. We're having some problems with the bearing right now, which is why you see that model that's not connected. It's just the individual rotation because that's our last data hurdle, I think.
Are you able at first things like, that a single bone can't be completely flipped in the opposite? Well, it shouldn't be, right?
Yep.
So based on that, does that help with your calculations?
Yes.
Things have certain bounds within each other?
That's a great question. Yes, we can take advantage of some anatomical facts that your fingers only bend in one plane.
Right.
So that definitely helps inform error correction, but we aren't that far yet. We have to get our bearings sorted out first. So, but it definitely works. It's now just a question of math.
And you can see the gravity he was talking about. If I keep my hand flat, you can see what in this Z direction is going down through the IMU. So if I can hold it flat, you can see a Z will come out to about 9.2, but there's some, so whatever that vector that it adds up to, you can actually see the gravity vector. So that was it's kind of neat to actually see it.
Yeah, the units in this column are all in G's. So 1G would be at sea level. Yep.
And this is an Angular app that we wrote. Gonna have to swap that out for React. Angular's no good these days. So
Can we show them the magnetograph? I'm sorry, I'm so hung up on that, but that thing is so awesome. Here's a
3D projector.
here's a piece of magnetized steel.
I gotta not trigger my gesture.
What's the magnet for? Are you doing heading and all that as well?
Yeah, there it is.
Oh, wow.
So if you can pitch the render around, because in two-dimensional display device, it's hard to tell where the vector is going. But when you pitch the render around, you can see that vector points right toward the knife blade. So,
So it's not just the position of the hand.
yes.
Other things.
The proper name for the algorithm that we're using is AHRS, which is Attitude Heading Reference System, I believe. So it's the same to your drone thing. It's the same code that people use to figure out what the absolute orientation of their craft is. So that same algorithm is what's in use here, among other things. We've got a couple in there at this point, but.
Well, I also have to use a common filter for position and things like that, which you can have.
Are you using inertial measurement units? Okay. Yeah, Kalman filter, right. I thought you said common. I'm sorry. Yeah.
To get rid of spikes and things.
Mm-hmm.
Well, basically, common filter, what it does is you get a whole bunch of bullshit input.
Yep.
And it tries to figure out the best out of it.
Yep.
Have you played around with the? Oh, I'm sorry. Go ahead.
No, keep going.
It's really cool to see like how much you're actually moving when you think you're like standing still.
Right.
That's a
Like
good point.
you don't
Mm-hmm.
you're moving very much, but look at all those numbers change
Yep.
so fast.
Yeah. Those sensors are very, very sensitive.
And this was fun to try to actually program a gesture. So the idea is that you would program your own gestures if you wanted to. It's a open source. You can download all this stuff right now, and Josh is just giving you raw sensor data. So you're getting all that, and you do whatever you want with it. So it's kind of fun to try to program a gesture. You can watch the graph. So if I flick my finger, you can see the peaks, and then you can program your gestures to look for those peaks in X, Y, and Z. So that started. The first one was like, okay, what do I want to look for? And I did it on gyroscope, so I looked for 200 was about my level. And so I'm starting to write kind of a gesture recognition framework where you could easily define a gesture just through a UI, and you could tell it what kind of threshold you want, so 100 plus or minus 5 if you wanted to.
Have you started playing around with the 3D screens, like the LG projector with those glasses?
No, but that's VR stuff's going to be the biggest. I think that's going to be the biggest
Yeah, give me your
application for it.
data. I'll show you what I'm doing for the simulation.
Want to fly a drone with it?
Yeah.
I do too.
Hold out, like,
Well, it's not just that, it's also for simulation. So I go out and get these $500 LG 3D screens,
Uh-huh.
and it gets driven by just a laptop. And if you do the software right, you can actually have a 3D output. You just put on these glasses like you do at a movie theater for 3D,
Okay.
and you'd be able to see a 3D view of a simulation, or a 3D view of the airplane flying through the air. So you're actually flying a 3D camera in a 3D simulated space that's tagged to real Earth. So you're seeing like background and you're seeing that, but if you look around, you'll see a simulation of the rest of your area where you're at.
Yeah. Those displays, there are a couple out there, but I don't know. That's someone else's problem to solve from where I
It
stand.
is. That's being solved now. But the cool part is that you can just take your data and just dump it into the framework, and you'll
Yeah.
be able to see a 3D hand in position.
That's like the last big thing that we want to get done is
Yeah. It's actually
to make it
really hard.
actually
It's actually really easy to do.
to make the render. It's a sensor issue right now. So once our sensor data is good, then making the sensor match to that quaternion model, you can see the actual hand graph
So all the processing that you're doing can be done on a laptop, I assume, right? You don't have to like send it into a cloud.
Most of the sensor processing is done on.
Yeah. Yep.
Wow.
I'm just taking the data and then defining gestures with it. But the hardest work is that sensor processing and giving us. I get one big object basically that's a frame, and that represents this. So I get this, and that's just a big JSON object. He sends it as a bit stream.
Could you step through kind of an order where the bits come off the sensors and go to the processing and into Node.js and back out to the.
I'll let you start at the glove.
Oh, okay.
Just a the parts on the pipeline there.
Yeah, sure. Well, the first part of that pipeline is going to be replicated 17 times, once for each sensor, and then 3 more times, once for the magnetometer, accelerometer, and then for the gyroscope. So we have those 3 streams from 17 places all coming in. Each of those sets of 3 gets fed into the quaternion operation. Right now, we're running those sensors at about 400 hertz a piece. So there's 400 samples per second coming off the gyro and the mag, and then 50 hertz for the mag? I'm sorry, the gyro and the accelerometer, and 50 for the mag. So at 400 hertz times 17 IMUs, that data gets fed in. That gets sent anyway, but it tees off, and then it goes to the quaternion operation. And we're doing that about 6,800 times per second. So there's a lot of floating point going on right now.
And that's happening in the wrist.
Yep. We still have headroom to go. I think we can get to about 11,000 quaternion operations per second before I have to start optimizing aggressively. But after that, the results of that quaternion get put into the same buffer alongside the root data, and then all of that gets sent over the Bluetooth link. So we're using the RN42 in here. We're pushing about 48K a second at that frame rate, something like that. So our bandwidth requirements are pretty modest. There's an SD card in the thing, and we retained the SD card for R1, and the idea is that you don't want to have to be around a PC all the time, because there are a lot of applications where I can't send all that data at 400 hertz across the Bluetooth link, even if it was running at the full spec of 3 megabit. It's just way too much data. Exactly. Yep. And for that reason, we have to be able to cache the data locally somehow, because if you're doing, you're walking around, you want to do sign language capture, you're interested in every nuance, and if you drop a frame to the PC, it's gone, because it's all inertial. So if you drop a frame, your data's trash after that. So we can cache it locally, and then it can be downloaded to a host offline for later processing. But
400 hertz kind of based on the type of resolution you want.
Yes.
So that's what you're looking for.
Yep. That's a complex issue, because if you run it at 100 hertz, you still get the same inertial data, but you get less granularity in it. So there are certain kinds of things that you can't capture. At 400 hertz, you can press one of those accelerometers to the wall and hear the air conditioner running through the accelerometer. It's that sensitive. So you wouldn't be able to get it at 100 hertz though. You're not really interested in hearing air conditioners though. You're interested in capturing hands. But still, people can make some amazingly fast movements with,
400 times a second would make a difference. That seems awfully fast.
It is.
This is a lot happening.
Yep.
Oh, not only that, you have to be exactly 400 hertz. You can't have any jitter.
Yeah, keeping that, those are solved problems for us by this point. We can keep all of those frames in lockstep pretty well. In fact, Brent, could you all tab over to the console? It's easier to ask you to do it now. Let's see how many. Oh, we're not plugged into USB. I have no debug. I could tell you exactly how many samples have been read out of every sensor.
You said you're transmitting like 2 channels of data at the same time, one that's processed and then
Yep.
one that's raw data.
Yep.
So you're doing that right now. You're binding with Bluetooth 3 and getting a single serial stream that you're doing the processing on.
Mm-hmm.
When you move this over to BLE, you're going to have like characteristics, and you can put these on separate channels. So is the idea then that you can throttle these things independently and say,
Yes.
I want raw data or I want processed data?
Yes. We have a strategy for that, actually. It doesn't even have to involve the protocol stack. We can do this over the COM port. We can do this over TCP/IP. We can do it over IRDA. The way that we handle it is we have a thing called a map legend. So that, like you read a map and you have a legend on it that tells you how to interpret all of the data that you see in front of you. So we have this similar kind of a concept where we say, okay, all of the data that I'm going to get back, here's the order that I want it in. Like the host to the glove says this. The glove takes note of it, says, okay, he only wants this. And then it arranges in pointer arithmetic to build the buffer. and there's no CPU cost to do it. It takes me 0.2% of my CPU per frame per second to send that data. So it takes almost no CPU because all of it's DMA driven. It costs memory bandwidth.
Is it always raw, or are you like wrapping it in a proto buffer or something? Like,
no, it's raw. It's all just a raw
so
bit.
how do you know when it starts and ends?
Because we have a frame for it, I guess. I shouldn't say it's exactly raw, but
So
it's.
you have some null terminate or something on it, right?
We have the packet. Every packet leads with 8 bytes, and the byte order is the first byte, or the first 3 bytes are the size. Then we have 1 byte checksum. Then we have 2 bytes for a unique message ID, and then we have 2 bytes for the class ID of the message.
Okay.
And then optionally, we have a whole bunch of data after that. So when the host gets the first 4 bytes, it knows the length and the checksum, and so that immediately prevents us from having to guess about where the packet ends. Additionally, the protocol also has a concept of MTU. I don't know if anyone knows about maximum transmission units. So that if a packet comes through that's 10 megabytes, because the protocol supports that, but that thing doesn't have 10 megabytes worth of memory, so it'll have to reject. It'll take the unique ID in that message and say, I can't handle that. Do something smaller. So all of that stuff is working really well now. It negotiates all of that stuff automatically. We have never talked about this, and I keep pressing Josh to do it because it's really interesting. But that API is completely self-defining now. The one that's running in that panel uses a completely different API, but it still auto-negotiates. So if you have some general program up there, like these guys have written in React, you should get. Do you want to show them the dropdown?
Which one's that?
The dropdown in the main window, the thing that gives you all the different messages that the thing supports.
And I'm still trying to imagine where the data goes after it takes off over Bluetooth.
Oh, that's right. You wanted to hear about Node.
Sorry, yeah.
A lot of interesting stories.
Can you pull up PHP?
It's right there.
Real quick. Can you? Okay, so.
Yeah, there you go. So those are glove model is the thing that's actually producing all this data. One glove model message transmits that whole block. So that's what, 960 bytes, including our packet overhead. So 960 bytes times 40 frames per second is whatever the bit rate is there. You can figure it out. But so we have a bunch of other things up here. Legend messages is what we transmit to say, here are the messages I support. Legend types, reply, fail, reply, retry, self-describe. It's the way the device has to, it's part of the protocol that we specified so the device can describe itself. It's like, here's my MTU, here's my identity, here's my serial number. Authentication challenge, session establish, hang up, and I think that's all we're exporting right now. We also have stuff in there for device specific stuff like that one. The panel has a draw frame buffer, for instance, which this doesn't have, but it doesn't matter because it follows the same protocol rules. But yeah, so it's after, to answer your question, after it gets all put into that buffer, it gets tagged with one of those message types. Go ahead.
I've got a bit flying through the air on Bluetooth. Who catches it?
My host.
Oh! No.
That's where you left off. Can you, I'll tab. Thank you.
Have like multiple gloves and the whole bodysuit and all of that?
Multiple gloves.
Multiple gloves, yes. There's Node.
Yeah. Well, so right. Yeah. So the idea is Node handles all this, and so far we've had no performance problems. You can see how fast the sensor data updates just from Node.
Oh, good.
But the plan is to so Josh has written a parser in C, and we might bring that into Node to handle that faster part. But this.
Your guys' stuff runs so well, though. I don't see any reason to take the time to do that. Runs very fast.
Oh, was that not DHP?
That's my source code, but
The code for DHP though? The Node stuff?
I don't have that loaded up in an editor. Do you want me to?
That's okay. So it comes into Node, and then in Node we've written a parser in JavaScript that takes that bit stream, and like he was just talking about, we expect a certain protocol. So we expect a certain length, a certain number of bits, and we grab that, and then we can build that glove model from the parser. So it goes parser, and then we have it kind of jump around a little bit, but a callback gets fired once that object's built, and then we have an execution list, and so for us, we use socket.io to emit that model, and then on the client side, we grab the model in socket.io, and then show it in a table.
Here, connect to the socket with the client side app and start.
Exactly. Yeah. Okay. And
Yeah.
so you can connect to it from your computer right now. You can dial into this.
Yeah.
And
Let's.
see our data streaming.
Yeah, let's get the IP. You won't tab me again.
I always, yeah, it's amazing how quickly we can prototype some of this and just get it working with JavaScript. Yeah, I had to write some C for that robot.js thing, I was trying to just expose some C that someone else had written. I'm just trying to expose it to Node, and it was it's it's a whole different world in JavaScript.
To get to Bluetooth, though, when you're just using Bluetooth 3.0 serial port profile to do the pairing,
Yep.
is that it? So that it's just another serial device, and then Node serial port to read it, and then you do the processing on that device.
Yep. Yeah, Node serial port.
Yeah, and
That's what I'm saying. So microchip can do something like that, would clear out a hell of a lot of problems with the industry. Do you think?
Well,
This is so easy.
Yeah.
It's crazy how easy this is.
Have you guys considered doing an exoskeleton instead of a glove?
Like all over your body.
No, just on your hand. So like
Actuators?
the sensor is just like connected to a little thing that goes around,
Yeah.
and then maybe adjustable. So
We honestly have a lot of ideas of how we could go about it. That is a really cool one.
Yep.
I don't know how to make it happen, but
this little thing, and then I don't know
what's the thing?
Like a little.
I don't know. You 3D print it probably.
like a
So I'm thinking like a kind of like I'm thinking like circular.
Maybe a
Yep.
quarter, or
Like a split ring.
maybe.
Yeah.
Yep.
Exactly. And then just kinda
I think that would be a lot cooler because you don't
Yeah.
have to wear the glove.
It can't be metal.
This whole thing around your hand.
Magnetic.
Pick up things.
Yeah, but
use your hand.
yes, the
Yeah.
Oh,
we can think of a good way
the
to
square
do it.
holes.
Yeah.
Yeah,
Easier
spiral
Oh
binding.
no, for right now I'm just
Yep,
saying end product.
that would work really well.
Yeah, but even for end product, it's
The next revision, the
none of us
digits will be
are
silicone
industrial
cast, so they're all
designers.
waterproof.
We don't have, that
But
skill set, but
yeah, having a textile-free version would be very nice. We're gonna try it for sure. I don't know if it'll stick or not, but yeah, it would be nice to have the thing not require your hand to be impeded in any way, including having a textile in between you and the rest of the world. So it's
You could possibly skip Node altogether and go directly in browser with Chrome serial port, because if you're doing a bind and getting just a device like a TT whatever,
okay.
that's what I'm doing with Chromebox is just going directly. In that case, you could skip. You might get better throughput as well because you could skip Socket.io, which is also doing some buffering and negotiating in all the WebSocket.
Yeah.
So there's a little bit of overhead there. So and then just do your visualization in WebGL, whatever, just directly from piping that stuff in and churning on that data. Since you're doing it in JavaScript anyways, it's probably all
Yes.
browser fileable.
we could just move that parser onto the client side.
I did have a little bit of trouble keeping a serial port profile Bluetooth thing passed through to Chrome, but that might just be a bug. But it's in theory, all of this stuff could be completely browser based.
Yeah. This is our goal. Is that I kind of view like within the team, I view my responsibility is to make a piece of hardware that a software engineer would want to use. So like hardware isn't necessarily my first goal, but the hardware that's out there now is either non-existent or it sucks or it's closed. One of those three things, and I don't want to use any of it. So once we get the hardware done, people with those kinds of ideas, we want them to be able to pick it up and just make it roll and not have any kinds of intellectual property impediments, no kinds of, oh, well, maybe this isn't, we don't want to have anyone have to deal with that stuff. We'd love to be able to see everybody just pick it up and use it as they like.
And you have our open source implementation
Yep.
of Node on here, so yeah.
And you have mine in C as well.
Is
So
there parser for the byte stream already NPM?
No, so we need to don't look at our code yet.
Dude, release early, release often.
We have a lot of cleanup to do. It's all one big monolithic beast right now.
Or maybe break it into modules.
Yeah, so that's on our roadmap of. So we're like trying to make things work and just get things to make sure it makes sense. But now it does. Things work. So it's time to do things like that, like break our stuff into modules. And
You ever heard of the line, build one to throw away?
yes, I have. Whose was that? I forget who said that. I use that all the time though. Who was it?
Or from South Carolina.
Who was it?
Fred Brooks.
Fred Brooks.
Yeah.
Build one to throw away. You will anyway.
And that and many other lines came from this book called Mythical Game Life.
Okay, is that where that's from? All right. Yeah, so that's the state of things.